Okay, welcome back to pre-calculus. We have some identities to prove. I think I'll try to do two of these in one go because they don't take that long. But we are going to try to prove the identity cosine plus 1 minus or divided by cosine minus 1 is equal to 1 plus secant divided by 1 minus secant. So with identities, you may do this in one of two ways. You can either start on the left or you can start on the right. It is completely up to you. Since I've done this problem before, I'm going to go ahead and start on the left. If you don't know, they usually set them up that you should start on the left. However, in this case, because I know what I would do with secant, if I was approaching this problem raw, I might decide to start on the right. But you're not allowed to cross paths. You're not allowed to cross multiply or anything like that because that's not allowed. Okay. So you have to pick one side and then make it look like the other side. Okay, so I'm going to pick cosine theta plus 1 divided by cosine theta minus 1. And what I'm going to do is I'm going to multiply by 1. I'm going to multiply by 1 over cosine divided by 1 over cosine. Okay, and what that's going to do for me is I'm going to end up with cosine over cosine plus 1 over cosine. I'm just distributing this 1 over cosine to both of the terms. Big fraction button here. So same on the bottom. We're going to have cosine theta over cosine theta minus 1 over cosine theta. And then say that that's equal to cosine over cosine is a fancy way to write 1 plus 1 over cosine is going to be secant theta. And then divided by cosine over cosine is 1 minus secant theta. And I believe that was what we were trying to prove. Like I said, if I didn't know where to go with this and I hadn't done this problem before, I probably would have started on the right-hand side because I would say, oh, it's 1 plus 1 over cosine, over 1 minus 1 over cosine. Gotten myself some common denominators and see what would have happened. Okay, in which case I would have gone from the right side to the left side. All right, let's look at the next problem. So the next problem looks like we have a 2 sine theta cosine theta squared. Okay. So we're going to say that we have a 2a sine theta cosine theta squared, and then plus, what else do we have here? Okay, we have an a squared, and we have a cosine squared theta minus a sine squared theta squared, right? Now, this one is, we're going to say that this is equal to a squared. Clearly, we're going to start on the left because I can start on the right. I got a squared. I'm like, great, I've got a squared. I have nowhere else to go. Like, I can say, well, it's times 1, and what do we do from there? Like, yeah, there's not a whole lot we can do with that without being creative. Again, if you knew where the problem was going, you'd say, oh, I know what to do. Yes, because we know where the problem is going. But there's a lot to do on the left-hand side. Let's go ahead and do that. Okay. So the first thing that I'm looking for is saying that let's go ahead and square this side out a little bit. So I have an a squared. I'm just going to move the a out of the way because I think it's getting in the way of what I'm looking at. And I have a 2 sine theta cosine theta, and we have a squared here plus an a squared. And now I have a cosine squared theta minus sine squared theta squared. Like, okay, at least I've gotten the a's out of the way so that I know that where that a squared is going to be. I'm probably going to factor some stuff out and figure what happens. So now I'm going to go back and think to myself, huh, 2 sine theta cosine theta. That feels awfully familiar. That reminds me of the double angle formula for sine. So I'm going to say this is going to be a squared times, and here I have sine of 2 theta, because that's 2 sine theta cosine theta, and all of this is squared, okay? Plus a squared, and now I'm thinking about this. I'm like, oh, wait a minute. Cosine squared minus sine squared, that reminds me of the cosine of 2 theta squared. And then what we're going to do is we're going to say this is a squared times sine squared of 2 theta, that's how we would write it, plus a squared cosine squared of 2 theta, because that's what we're going to do for that. And now what I'm going to do is factor out my a squared, so I have a squared, and now we have sine squared of 2 theta plus cosine squared of 2 theta. And if this section taught you anything, it's sine squared of a thing plus cosine squared of that thing is equal to 1. So we have a squared times 1 is equal to a squared. And I think we have proved our identity for this one here. Okay, so try to be on the lookout for those. Try to make sure that you've memorized your double angle formulas and such, and see if we can't go through that. Some of angle formulas are important too here. Okay, so with that, I'll say thank you very much for watching, and I will see you in the next video. Thanks.